Today let us learn the law of radioactive decay. So let us consider a radioactive sample which contains n0 number of nuclei. That is, when t is equal to 0 initially, the number of nuclei in the sample is n0. At any instant t, the number becomes n. The nuclei undergoes disintegration and the number decreases to n. It is found that the number of nuclei undergoing decay per second, that is per unit time, is proportional to the number of nuclei present in the sample at that instant. That is dn by dt, change in the number of nuclei per second, dn by dt, proportional to the number present at that time, present at any instant t, that is n. So dn by dt proportional to n. So we can remove the proportionality sign. That is dn by dt is equal to a constant lambda n. Lambda is known as decay constant or disintegration constant. And as the number decreases with the time, we are giving a negative sign also. As time goes on, the number of nuclei remaining in the sample decreases. So let us find the value of n. So let us cross multiply and find dn by n. dn by n is equal to minus lambda dt. Let us integrate. Integrating both sides. Here the number, initial value is n0 and the final value is n. So the limit is from n0 to n. And here the time, the initial time 0 and the final time t, 0 to t. An integral dn by n, that is natural logarithm of n. And the limit is from n0 to n is equal to lambda is constant, so minus lambda into integral dt is t, and the limit is from 0 to t. First let us apply the upper limit, then minus lower limit. So this is log n minus log n0 is equal to minus lambda t minus 0. Log a minus log b is log a by b. So this is log n by n0 is equal to minus lambda t. So let's take the antilog. N by n0 is equal to e raised to minus lambda t, or n is equal to n0 e raised to minus lambda t. That is, the number of nuclei decreases exponentially with the time. The rate of decay is known as activity of a radioactive sample. Activity is the rate of decay, and that is equal to minus dn by dt. And dn by dt is minus lambda n. So minus dn by dt is equal to lambda n. So rate of decay is proportional to n. Or let us substitute for n. R is equal to lambda n0 e raised to minus lambda t, or r is equal to lambda n0, that is a constant, and that is r0 e raised to minus lambda t. So activity also decreases exponentially with the time, where r0 is the initial activity and r is the activity after a time t. That is, the number of nuclei decreases exponentially with time. N equals n0 e raised to minus lambda t. Now let us say half-life. Half-life is the time at which the number of nuclei becomes half the initial value, or rate of decay becomes, or activity becomes half the initial value. That is, when t is equal to 1 half-life, the number becomes, initially the number is n0, and the number becomes, after half-life, the number becomes n0 by 2. After 2 half-lives, the number again reduces to half, that is n0 by 4. After 3 half-lives, number becomes n0 by 8, and so on. That is, when t is equal to t half-life, n equals n0 by 2. So let us substitute in this equation. N equals n0 by 2 is equal to n0 e raised to minus lambda t half. Let us cancel n0. Then 1 by 2 is equal to e raised to minus lambda t half. Let us take the reciprocal. 2 is equal to e raised to lambda t half. And let us take the natural logarithm. Natural logarithm of 2 is equal to lambda t half. Or t half is equal to natural logarithm of 2 by lambda. So let us convert natural logarithm into common logarithm. That is 2.303 log 2 by lambda. And log 2 is 0.301, and let us multiply 2.303 into 0.301. It will be 0.693 by lambda. Or half-life is inversely proportional to decay constant. From the graph, it is clear that when time is 1 half-life, n equals n0 by 2, or n by n0 is half. That is, the number becomes 50% of the initial value. After 2 half-life, the number becomes 25%, or n by n0 is 1 by 4, or half whole square. When time is 3 half-life, n by n0 1 by 8, or half cube, or the number becomes 12.5%. After 4 half-life, the number becomes 6.25, or n by n0 is 1 by 2 raised to 4. So after n half-life, n by n0 will be half raised to n, where n is the number of half-life, that is time by t half. We can use this relation for numericals. Now let's see the mean life. Mean life is the time at which the activity or the number becomes 1 by e times the initial value. That is, when time is, mean life is denoted by tau. When t is equal to tau, n is equal to n0 by e. E is a mathematical constant. Its value is 2.718. So n0 by 2.718 is equal to 0.368 n0. Or you can write it as 36.8% of n0. So mean life is the time at which the activity becomes r0 by e, or the number becomes n0 by e. So let's substitute in this equation. N becomes n0 by e. E raised to minus lambda tau. And let's find the value of mean life tau. N0 we can cancel. So e raised to minus 1 is equal to e raised to minus lambda tau. Equating the powers, minus 1 is equal to minus lambda tau, or 1 is equal to lambda tau or tau is equal to 1 by lambda. Mean life is 1 by lambda, while t half is 0.693 by lambda. So t half is equal to, in terms of mean life, we can write it as 0.693 into 1 by lambda. 1 by lambda is tau. So 0.693 tau. This is the relation between half-life and mean life. Thank you.